self.appDelegate to the result of calling UI application shared application delegate. So this method call returns effectively a pointer to the UI application that was created by main, if you think back to where the story always begins, and delegate returns a pointer to what? The app delegate, to whom UI application main, according to our story, delegated control. So this gives me a pointer to my own app's app delegate. How do I get access to the view controller? Well, self.viewController is going to get the return value of self.appDelegate.viewController. So why does this work? Well, recall the code that we keep taking for granted in appdelegate.m. In appdelegate.m, notice what it's doing. It's, yes, allocating the view controller, calling init with nib name, but where is it putting the return value? Well, there it is. Once I have a pointer to the app delegate, I can get a pointer to the view controller. So lastly, all we need is the sort of generic view that encompasses everything. So self.view, and this one's actually pretty easy. Self.view gets self.viewController. Take a guess. View. Now we have all three sort of macroscopic objects that are really interesting when it comes to my app's overall execution and its overall UI. So how do we test the app delegate? Well, this one's pretty easy, and frankly, it's probably not necessary to get into this habit, but let's just do it for good measure. stassert not nil, and then pass in what? Self.appDelegate, and then comma, cannot find the application delegate, or some such string. So this will be a little sanity check to assert that indeed the app delegate exists. So let's do something more interesting now. How do I go about testing the clear method, that it actually works? Well, on a high level, how would you go about testing the notion of, does your clear button work? What would you do in the real world? Yeah?
You call it and see whether it does what it's supposed to do.
OK, good. You call it, and then you see, or you press it in the real world and see if it actually clears the screen and resets whatever's on the screen to something like 0. So let's go ahead and try this. We need to simulate this now. So let me go ahead and do self.viewController, and I'm going to call the digit method, because I need to put something on the screen in order to actually have something to clear. So I'm going to pass in digit. What does digit accept as an argument? Here's the method in viewController. What does digit expect? Yeah, UI button. So recall that ID is sort of a generic pointer. Sender is the generic name given to the things that send IB action messages. So if I actually want to simulate a button, I could allocate a button, but that feels a little messy. Well, I can actually talk to my UI. I can say self.view, and then I can say, let's see, yep, view with tag. And then I can say, well, give me, let's pick a number, 1. In other words, let's go ahead and type 1. Or let's be more specific, simulate typing just the number 1. So recall that we tagged everything in Interface Builder. What did this mean? Well, let me go back to the nib file. Let me click on the 1. Let me open all the inspectors on the right. Let me click the attributes inspector. And then remember, like 2 or 3 weeks ago, I went down here and then said that I need a programmatic way of uniquely identifying each of the numeric buttons that's not just their string label. Well, there I had 1. So what does this do over here? If I go back into application tests, this method here, view with tag, will literally return to me a pointer to what type of object? Sanity check. A UI button, which descends from a class called UI view. So a button is indeed a view. So what did I do? I literally just simulated typing the number 1. So if I did this correctly, let's go ahead and do this. stassert and true. And now I want to go ahead and assert that self.viewController.deposit label, his text is actually is equal to string, quote unquote, $1. And if not, I'm going to go ahead and print something like deposit should be $1. So in other words, I want to assert that it's the case that the text of the deposit label property is equal to the string, quote unquote, $1. And here, little check, why didn't I not just use equals equals? Yeah.
to test that too, and a strings point to the same or a same pointer.
Perfect, right? So you don't want to compare the pointers. You want to compare the actual string values, which is equal to string. We'll actually compare them char by char. Now, if I go ahead and click on the error here, expected identifier. Oh, where am I missing? OK, there we go. I had an extra square bracket. OK, so what did I do? 1, I simulated touching the number 1. And then 2, I'm checking in the UI, does what's appearing in the label right now actually match what I, as a human, expect should appear in the label? And notice that I'm using my same IB outlet called deposit label. What is that thing? Well, again, a quick refresher. If I go to my H file, recall that we had these properties a couple weeks ago, a pointer to an account, a pointer to the UI label, a pointer to the deposit. And then if I look in the nib file, and actually right-click on this, I see that deposit label is indeed a blue line that I dragged and dropped over to file's owner, the view controller class. So in application tests, the goal was to test the clear method. How do I test the clear method now? So clearing should yield $0. So let's go ahead and test this. So self dot, whoops, so do self dot view controller. And I'm going to go ahead and pass it the clear message. And what do I pass it as an object? Well, to be honest, it actually doesn't matter in this case, right? Because anytime I press the clear button, it's only wired to one method. So if I look over at the clear method, which is over here, notice, am I even using the sender argument? No, so I can kind of cut a corner here because it doesn't matter. And I can simply pass in nil and not have to worry about tagging also the clear button. It's just not necessary. So what do I want to check for after I've simulated hitting clear? st assert true what? What should be what? OK, I'll keep playing. So deposit label text is equal to string. Come on, 0. All right, so that's it. So now we have a test in place that when I run this test suite, it's not just going to test my underlying models, which is purely code-based, has nothing to do with UI and interface, but rather here, I'm testing really the user's interactions by simulating the key presses, sending the exact same IB actions that would have been passed themselves, and then talking to the IB outlets to making sure that the UI is responding to those actions in the manner that we expect. So let me go ahead and rather than write out a whole bunch of these somewhat tediously, let me go ahead and open up a pre-baked version that has exactly the same code, but also some additional methods, just so we can take a quick peek. So this is the same overarching thing. Notice I have 3 targets up here, just as before. And in my M file, notice that all of this is the same as we just typed, same as before, same as before. How about deposit? Well, deposit, this is why it was going to get a little tedious to type. Notice the kinds of things I do. So I want to test the deposit button. Recall that test deposit is going to be the first thing executed after setup. So what do I want to do? I want to talk to myself here. Balance should be $0 at first. So I write a comment to that effect. I then try to assert that it is indeed true that the balance label's text is equal to the string, quote unquote, 0. And what's going to happen if this assertion fails? That's it. This method will terminate. I'll get a red message on the screen. My other tests might still run, but I need to fix this before I can proceed to test yet other things here. So now I pretend to deposit $1. How do I do that? Well, just as before, I pass to the view controller the digit message, and I pass in view with tag 1 to effectively simulate pressing the number 1. Then I go ahead and simulate pressing the deposit button, passing in nil, because I don't care about what button hit deposit. There's only one of them, just like the clear button. And then I assert a couple of things. Once I hit deposit, I want to assert that the deposit label is now 0 and the balance label is now 1 because it's been moved from the top of the screen to the bottom of the UI. Then I didn't want to stop there, right? I could still have something wrong whereby maybe the first deposit works, but the second one doesn't. So this time, let's not only try depositing a second amount, but what also have I consciously chosen to deposit here? Not just another $1, but a 2-digit value, right? This is the opportunity to think about, like, what could I have screwed up? Did I screw up corner cases like double-digit numbers or triple digits? Certainly something more than 1. So let me wave my hands at some of these details. But after I deposit $12, I should hopefully see $13 in the balance. And then I figured this was enough unit tests. Now, if I realize subsequently that, damn, my TF or I found some other bug in the code, writing a regression test would be about going back in here, writing a new test that tests some other thing that I wasn't anticipating, and then making sure that that subsequently always passes. What about testing digit? This one's a little more interesting because there's a lot more corner cases to consider. So when I push a digit button, like the number 0, what should be the case? Well, by default, the deposit label should be $0. If I input a leading 0, this is a good one to test. So let me go ahead and simulate the digit message with an argument of the 0 button. And what should it be at the end? Should still be